So this part of the lecture will deal with contact forces. Contact forces are forces that arise because of the interaction between atoms in the surfaces that are in contact with one another. For example, these include friction and normal forces. This means that these are forces in which one body exerts a force on the other because of some direct contact between them. So contact force number one. The normal force. The normal force is always exerted when two objects are placed on top of one another. For example, if there was a book that was placed on top of a table, then the normal force will be due to the table holding the book up. Weight will also act all the time in order to counteract the normal force that's there. If someone was to apply, say, a force P on the book, the F net of the book will become W plus P. The table will keep increasing the normal force in such a way to counteract the applied force. But if the applied force becomes too large, the table will eventually give in and the book will fall through. So normal force acts in a direction perpendicular to the contact surface. In general, students have made this mistake of always assuming that N is going to be equal to the weight of the object. This is actually not true. So in a case like this, for example, if the object is sitting on an incline with a certain angle theta with it, the weight is not equal to the normal force. The normal force always acts normal to the surface, but the weight will always act downwards. So we will do an example very similar to this on how to handle situations like that. Okay, now let's combine the two contact forces that we've talked about and come up with how to solve this problem. So a box full of books rests on a wooden floor. The normal force that the floor exerts on the box is 250 newtons. You push horizontally on the box with a force of 120 newtons, but it refuses to move. What can you say about the coefficient of friction between the box and the floor? So in order to solve this, what we are going to do is we are going to make a free body diagram of your box on the wooden floor with all the respective things that are given to us. So here's my box full of books, right? And it's sitting on a floor. What is the one thing that I can absolutely for certainly say about my box? Well, there is always going to be a weight that is acting downwards. And since these two surfaces are in contact, I can always say that there will be a normal force that is acting upwards. Now it says that you push horizontally with a force of 120 newtons. So let's say you push it in this direction. And it is 120 newtons by which you pushed it. And your normal force it gives you is 250 newtons. Okay, now it says, what can you say about the coefficient of friction between the box and the floor? So first things first, which direction should friction be? Friction has to oppose your motion. So in fact, if you look at it, if your force is that way, your object will want to move that way. So that means your friction has to oppose it, and it has to be this way. Now noting, I know from Newton's laws I can rewrite them as sigma fx and sigma fy. Find out all the forces that are acting on the x-axis. So let me say that this is my x and this is my y-axis. So all the forces are acting on the x-axis. Well, there's my force applied that I am pushing it with, and then there is a frictional force. Okay? And since this is not moving, I know it is static friction. Positive x direction, positive applied force, come up with plus here. Minus static friction. Okay? Now, chosen coordinates, y goes up. That means normal force is going to be plus, and my weight is going to be minus. Since this is not going anywhere, there's no acceleration present, I can simply say these two are equals to 0. Which means from equation 1 and equation 2, F applied is equals to static friction. And from 2, I can rewrite N is equals to the weight down. from the last slide, another thing I know is F friction is always equals to mu S, right? This means from this expression, if I plug this value in here, this means mu S mg is going to be my static friction. This implies that F applied from here is equals to mu S mg. Okay? So F applied is 120 newtons. Mu S is just N. Oh, I was given N, so I didn't even have to worry about converting it. Newtons. And mu S will now equals 120 divided by 250, which comes out to be 0.48. So this is going to be my coefficient of static friction. Part B. Now, if you must push horizontally on the box with 150 newtons to get it to start sliding, what is the coefficient of static friction? So now the question is that it is just starting to slide as you apply more force to it. So for part B, you need to apply a force of 150 newtons to get it to start moving, right? So basically you're pushing F applied is equals to F of S, which I get from equation 1, right? Which means this is equals to mu N, and now this is going to be my static friction. What happens to the normal force? Does the normal force change as you go from a static condition to a kinetic condition? Absolutely not. Unless the surface in contact is changing, your normal force will remain exactly the same. Okay, so this means F applied is now equals to 150 equals mu S 150 newtons. Oh no, it's 250. What am I talking about? Okay, so this is 250. I applied it in this, so it'll be 150 divided by 250 equals mu S. This gets canceled with this. 15 divided by 25 gives me the value 0.6. Now for part C. It says once the box is sliding, you only have to push it with a force of 120 newtons to keep it sliding. What is the coefficient of kinetic friction at that point? Now, part C is saying that now we are looking for kinetic friction. So we are looking for mu K. Now again, will the normal force change? No, the surfaces are still the same, so the normal force cannot change. So mu K will now be equals to F applied divided by N, just as what we have been doing here. F applied divided by N equals mu S. Mathematically, the formulas are exactly the same. But in this case, what is my applied force? It's 120 newtons divided by, what was my normal force? 250, which cannot change. So mu K is actually equals to 0.48, which is the same as here. But what is the difference? The difference is, and at this point it was not moving, it was static. This is the maximum static coefficient, and this is the coefficient of friction once the object starts to move.